This is my biomedical signal processing circuit system. It is supposed to acquire the sound from a stethoscope. Its design should allow end users to listen to the heartbeat from the speaker. I will now be explaining the circuit in stages. In stage 1, ICA1 ICTL072 is a dual low noise JFET input general purpose operational amplifier. It supplies a voltage gain from 10 mV to 1 volt. However, it does not supply current. The operational amplifier amplifies the sound where subtle shades in the character of sound can be added or subbed. Based on the circuit, it is a fixed gain closed loop non-inverting operational amplifier. The circuit also needs to bring the signal from electret mic up to a level suitable for a line input. C1 blocks the DC bias voltage from input. The voltage divider consisting of two 10K resistors will provide half the supply voltage, which supplies in the operational amplifier to be working at a single supply mode at 4.5 volts. R2 and R3 with C2 and C3 forms a bandpass. Filter bandpass gain is 23 using 1 plus R2 over R1. Coupling capacitor C4 couples output from first amplifier. So if DC input offset were to be amplified, there would be a larger output offset. The output waveform will be cut. Hence, C4 passes AC signal whilst blocking DC. Based on the table shown, for amplifier in stage 1, the higher the frequency, the higher the gain, with its max being at 23, which will be equivalent to 27 decibels once at 100 Hz. Surpassing 100 Hz, the gain will begin to decrease in value. Based on the graph below, the negative 3 decibel line is at 24 decibels, meaning F1 will be at 26 Hz, while the FH will be at 12,000 Hz. Therefore, bandwidth will be at 1074 Hz. As the single supply mode causes the negative side of the waveform to be cut, the level shifter, also known as the voltage divider, will shift the entire waveform up, ensuring no waveform is cut. To set up stage 1, power supply is set up at 9 volts and is connected to the circuit. Secondly, the function generator frequency is set to sine wave at 1 kHz with 200 mV peak to peak. By connecting C1 probe to test point 1, the output voltage is somewhat above 200 mV peak to peak, and by placing channel 2 probe at test point 2, the output voltage I got was somewhere around 400 mV, as shown on the following clip. In stage 2, it also uses the same IC, however it is a negative loop amplifier. Negative feedback is the process where the output voltage of an amplifier is returned to the input with a phase inversion, meaning the trimmer controls the feedback signal that reduces the overall gain of the amplifier, which functions as a linear amplifier and will not saturate the output voltage. Voltage divider consisting of resistors R9 and R10 are connected to pin 5 of the IC. It acts as a level shifter, ensuring the output will not be clipped. In stage 2, channel 1 will be placed at test point 2 and channel 2 will be placed at test point 3. The output voltage I received was 4 volts, and by adjusting the trimmer, it affects the waveform of the output, which at some point becomes saturated and cut off as shown in the next clip. In stage 3, capacitor C5 will block DC and allow AC to pass. Voltage divider resistors R11 and R12 act as a single supply node for the second IC, as well as acting as a level shifter to ensure output is being clipped. For ICA2, a second TL072 IC is used as a Scallan's key second order low pass filter and is made up of two low pass RC networks. Capacitor C7 provides feedback for shaping the response near edge of the passband, allowing frequency to pass through whilst filtering out the high frequency. Output voltage from IC2A will pass through capacitor C8 to filter out any DC. Based on the table below, when frequency is below 500 Hz, filter is at a unity gain, but above 500 Hz, output voltage and gain will drop. And based on frequency response curve, negative 3 dB line will be at negative 3 decibels and FH will be 1 kHz, meaning bandwidth will be at 1 kHz. Connecting channel 1 at test point 3 and channel 2 at test point 4, I got a filtered output voltage of somewhere reaching 4 volts. However, there is noise on the waveform for channel 2 when conducting my circuit as shown on the following clip. In the last stage, a new IC LM386N-1 is used. It's an audio amplifier that drives the speaker and designed to be working as a single supply mode internally, meaning no additional voltage divider is needed. It is the only amplifier in the entire circuit that drives current to power the speaker. Capacitor C15 filters out high frequency that is above 40 kHz. Without it will cause the output waveform to be slightly unstable. Capacitor C13 will block out DC and allow AC to pass. Input will then go through trimmer P2, where pin E has full amplitude while pin A and pin S will have zero amplitude in input waveform. Channel 1 will be placed at test point 4 and channel 2 will be placed at test point 5. Output voltage received was near 1.5 volts, and by adjusting the trimmer, I was able to control output waveform at test point 5. However, as shown in the following clip, there was noise while conducting my circuit.